Hello everyone! Today we're gonna create a head bobbing feature for our camera. It will make our movements more realistic and interactive. We start by creating a new folder in the Blueprint directory. Name it Common. Next, we need one more folder. Call it head bobbing. Here we need to create a scene component. Name it BP underscore head bobbing component. Next, we need to create the last folder, which will store all effect types of our camera. Name it Types or Effects. We need the following types: for idle, for walking, for running, for crouching, and for jumping. For start, it will be enough. Now, let's create them. When creating a new Blueprint class, search for Camera Shake. Name them using the prefix CS underscore for camera shake. For example, CS underscore idle. You can create 4 left elements like we did it before, but you can simplify this procedure just by duplicating our newly created camera shake effect. Select, then use Ctrl W shortcut. Here we have another copy of our camera shake. We have all types of our camera shake effects. Just save them. Now, open our character and add our head bobbing component. Rename it as you like. Then compile and save. Next, open the head bobbing component. Let's add some logic. Firstly, let's create a reference to our character so the components will know its parent. Search for getOwner. Next, pull a wire and search for cast to our character node. Because the owner of our component is our character, the cast will proceed, and we can store the return value as a reference link to him. Use promote_to variable on the return value of cast2 node. Compile and save. Next, let's head back to our console browser. In the Blueprints directory, create a new folder and call it Enumerations. Go inside it and create new asset. Right click, look for Blueprints category and search for enumeration. Rename it to E layer state. Enumeration, or enum, is a numbered list, and in our case is more useful than bool or boolean when we talk about switching between states. Let's open it and add character states. The first element will be null or none, as you like. It's a good practice to leave the first as the unassigned element. Then we add 5 more elements and name them according to our states. Save and close. Now let's open our character and make a function that will return our current state. On the left side of your blueprint, find a category Functions, click on cross, then rename our function to getCurrentState. On the right side of your blueprint, look for Output, click on cross, then rename the variable to playerState and change its type E playerState. Compile, save. Now, on the left side of your blueprint, find a category named Local Variables, add one, change its name to Current State, then change its type to ePlayerState. Compile. Next, drag and drop character movement. Then pull a wire and search for isMovingGround. Next, isFalling. The last one is crouching. Next, right-click and search for getVelocity. Now our basic preparations are done and we can start creating our logic. Firstly, let's check whether we are moving. Search for equal vector Next, search for branch. Branch is our if condition. Connect pins. Here we have two options. When our velocity equals 0, it means the character is idle. So drag and drop current state from local variables. Use set current state. Connect and change current state to idle. When our velocity doesn't equal 0, it means we are moving. But how exactly? We need more branches to continue. I noticed one thing. Because we won't make our character be able to fly, for now, we can actually delete the isFalling node. Next, let's check if we are moving on the ground. If it's so, we'll proceed to the next condition. If it's not, it means that we fly or are falling or jump. So set new state, jump. From the last successful condition, let's check if we are crouching. If it's so, set state, crouch. If it falls, we have another condition. We are moving, but actually at which speed? Drag and drop character movement. Pull out a wire and search for get max walk speed. Check whether it equals our walk speed. If it's so, it means we are walking. If it's not, it means we are running. Connect pins. Then connect all pins to the return node. Next, drag and drop current state, choose get current state, and connect it to play state of return node. Check everything. Compile and save. Then let's head back to the head bobbin component and check how our states work. To check it, search for nodes. Tick event, print string, then drag and drop our character reference link, pull a wire and search for getCurrentState function. Connect them. Now launch the game and check all abilities. Idle, walk, run, jump, crouch, run, walk, jump, walk, run, walk, crouch, idle, jump, idle. Everything works fine. Now let's clean the mess we did earlier in our character, but firstly let's delete this, because tick is quite expensive operation and try to avoid it. Use timers instead. So you can start from cleaning all these wires. Alt left click on the exact pin of return node. Then we can actually delete current state variable, and we need to duplicate return node 4 times. Next, let's rearrange our blueprint, because when it's clean, it's much more easier to read through this blueprint. Well, I think it's quite okay. Now let's add logic for switching between camera shake effects. In head bobbing component, we need to create a timer which will check our state with a specific interval in time. Search for set timer by event. Now we need to create a custom event where we will initialize our logic. Search for add custom event. and rename it to switch camera states. Now drag and drop character reference, then pull a Y and search for get current state function. Pull a Y from the play state field and search for switch on enum. Next, search for Play Camera Manager. From it we need two functions: stop all instances of camera shake and play camera shake. The logic behind this is quite simple. We use only specific camera shake for specific state and discard the others. As we have 5 states, 4 states need to be discarded, 1 state should be active. To prevent a copy-paste math, we will create a function. Name it manage camera shake. The inputs will define which states to discard and which state to use. We need 5 inputs. First, let's call it add underscore CS camera shake. Change its type to camera shake and use class reference. Let's add more states. Call them remove underscore CS camera shake. Like this. Now let's add some logic. Go back to the event graph, cut our nodes and paste them into our function. Let's make it look more cleaner. Then let's add a sequence. Let's copy our stop all instances of camera shake node 4 times. Actually 3 times. Let's distribute them horizontally like this and align the child. Well, now it's look beautiful. Then we can actually don't connect these pins Because we use a function, we can actually call these inputs just by searching them into our menu. Well, they don't appear because we actually don't compile our function. So let's compile, then look for our pins. Here they are. Connect them. And one more for our add camera shake. Like this. Our function is ready. Compile, save. Now let's head back to our event graph and create 5 custom events. So any our state can have its custom logic. Search for add custom event. Call it idle underscore CS camera shake. Do this 4 more times. Like this. Actually, we need to add some space. You'll see why right in a minute. And let's begin with walk, for example. We'll skip idle because it's a little bit tricky, so I'll leave it the end of our video. Drag and drop our manage camera shake function like this and connect pins. Actually, you need some more space, so it's up to you. Make sure you have set up all necessary states for each camera shake function. Check them. Now, let's go and tweak them. We'll start from walk and run states. When you open camera shake blueprint, you can see a bunch of settings. You can read the description of each on Unreal's website, but I'll explain a few of them. we need a single instance of each class, so only one effect can be played at a time. For walk and run effects, we need to adjust our camera's pitch rotation amplitude. So check rotation escalation, then expand pitch. You can set any value you like. I'll provide those I find myself suitable. Amplitude is the angle or a wave power of the effect. Frequency is how often we need the wave to happen. And initial offset is for which point to start the effect with. You need to set up from random to 0. And for walk, the amplitude I'll go with 0.4, frequency 10. Escalation duration means how long our effect will play over time. As we move continuously, we need low values for perfect timing, so let's go with something like 0.2. Let's check. Compile and save. For the run state, I'll use the same parameters, but only change the amplitude to 1 and frequency to 15. Compile and save. Next, crouching. For crouching, we need to set the camera's roll escalation. For amplitude, I'll go with 1, and for frequency 10. As for escalation duration, it's the same as we did it in run and walk states, 0.2 and single instance. Check everything. Compile, save. Next, jumping. For jumping, we need to fake the landing amortization effect. We need to adjust that location. The amplitude -40, frequency 0.5, single instance, and 0.35 for escalation duration. Check everything. Compile and save. The last one is the idle state. For idle, we will fake the waiting effect. Set duration to something high so it will last longer, for example 120. Check single instance. Then we need to change the camera's yaw rotation. For amplitude, I'll go with 10, and for frequency 0.5. Compile and save. Now we are ready, and we can actually head back to our head bobbin component to set the rest of the logic. As I said earlier, the idle is a tricky part, so we're gonna adjust its logic right now. We need a timer and a custom event. We need this custom event to provide our idle state after a short period of time when we don't move. Let's call it start idling. I think I can spell it wrong, so I'll go with start idle CS, like this. Next, pull a wire from the event, expand add event, sorry, not expand, search for create event, like this. So we don't need to provide a wire from our custom event to our timer. In create event node, search for our custom event. Start idle underscore CS, like this. Now we need to add a do once node and one more custom event. This custom event will interrupt our idle state. And we'll connect like this. We use the once, so the idle effect will start only one time and last as it's set to its escalation duration. These events happen anytime we press our control keys. Now let's add our manage camera shake function and set it for our idle state. Then we need to adjust the timer's time. For idle state, for example, we go with 10 seconds. This means that when we don't move for 10 seconds, on the 11th second, our timer will go with start idle underscore CS event and we will play our idle camera shake effect. We need to save our timer. It's a good practice, so we can clear and invalidate it when we have to. Pull a wire and use promote to variable. Rename this to idle for start idle timer, like this. Well, for our switch state, we need to provide our custom events. So when the main event will start, our logic will play as intended. Idle go with idle, for walk with walk, and so on. Let's see. Next, let's connect these nodes and provide our main timer its custom event, switch camera states. Then use looping, so it will tick every time, and for time go with something small, so we will not see any artifacts. Something like 0.02. And one more thing left. In case we don't any artifacts, go to our manage camera shake function, and in all instances of this node called stop all instances of camera shake, dismiss immediately checkbox. So our transitions will be smoother. Head back to our event graph. Everything looks fine, except one thing. We need to call our interrupt idle state every time we use walk, run, crouch, or jump states. So let's call our interrupt idle underscore cs event. Like this. And after it, we need to clean our timer. Search for clear and invalidate timer by handle. Connect it and provide our idle timer. Now everything looks fine and we can check our game. I'm sorry guys, I have actually messed up with this part. We actually need the ones before our timer in the idle custom event state. So make rearrangements and connect it like this. And let's actually rename our interrupt idle event to reset idle event. Reset idle underscore CS. Now everything looks fine. Compile and save, and let's check how our game works. Right now I'm recording with NVIDIA Shadow Play, so the quality is much higher and the video is smoother. So let's check our head bobbing feature. As you can see, right now I am in the idle state and waiting for something to happen. Let's begin walking. Head is popping up and down. Let's run. Let's jump. Jump one more time. And one more. You can see the amortization effect. Now we are standing still and waiting for other idle event to fire. Well, that works. Now let's sit up. We are still in idle effect because we don't move. And now let's begin crouching. And we have some oscillations on our x-axis. Let's stop crouching and stand up. Well, everything works as it pretended to work. I hope you liked my video, and that's all for now. Make sure to subscribe, leave a like and comment. Any critic, even bad, is well for me. So, see you in the next video.